Pascal's triangle, what you have to do is you have to remember that it starts with ones. So if you do that, and you have to start it like a triangle. So we have, it has 1, 1, 1. Then we have here, you start with a 1 on every row, then you add up the 2 above it, so it's 1 and 1 is 2, and you end with a 1. And you want to offset it. So this next one is 1, 1 and 2 is 3, 2 and 1 is 3, and then we have 1. I want you to think of the next row. I want you to try for that next row. So it would be 1, 1 and 3 is 4, 3 and 3 is 6, 3 and 1 is 4, and then you offset it with a 1. I want you to try the 5th row, but on your paper, not out loud, on your paper. I want you to write the 5th row. So hopefully you got, class, what did you get? You got 1, 5, 10, 10, 5, 1. Alright. So the one thing is, the Pascal figured out that these end up being the coefficients of when you expand. And so the one thing all you have to do is remember that it starts with row 0, because row 0 only has 1, so that means that you would it would be to the 0 power, which you won't have. And then this one will be row 1. This is row 2, row 3, and I'll do one more, row 4, and so forth down. Also realize that, see how this is a 4? That's a 4. That's a 3, it's a 3. So we know that that's the 5th row. And the next one's going to have a 6. That's the 6th row. Alright? So you can tell also, so you don't have to really count them down, your row will be the same as your second number in. Right? Alright, so what that does is it helps you to be able to expand things. So we have here, I will tell you, if you pay attention to me and not do like other things that you're doing that you and you pay attention, it'll be easy. If you don't pay attention, it's going to be a little tricky. So make sure you do pay attention. The first thing that we have is this degree tells you what row to go to get your coefficients. So it's degree 2, so I go to row 2, and these are my coefficients of my answer. So I'm going to, the first step is to grab your coefficients. So I have 1, 2, 1. So I'm going to put 1, 2, and 1. The second is to do your x, or your whatever, your other variable that's here. So I'm going to say x, and it's going to be whatever your degree is. So I have x squared, and then I count down. So I have 1x, and then I have no x. So x squared, x, no x. Then you do your other variable, which is y, and you count up. So you have no y's, so 0, 1, 2. Now, this one is a very simple one, and the reason why I did it like this is so you can also see how we used to do it, which is your FOIL. And I'll tell you why we're not foiling it out. But x times x gives me x squared. Inner and outer, we had x and y is 1xy, and another xy gives me 2xy. And last, y and y gives you y squared. The reason why we are not going to FOIL out is because right now that's a square. This is a cube. So that means I would need 3 of them. We're going to go up to 6 of them, so you'd have to have 6 of them. So you'd have this 6 times. So you want to make sure, you wouldn't want to have to foil it, distribute it, distribute it, distribute it 6 times. So that's why the Pascal's triangle is very nice. So I want you to flip your paper over, and we're actually going to do number 1 on the back side. So the first thing I want you to do is I want you to do a small Pascal's triangle. Don't do it very big because you'll need your space to write. But we're going to do a small Pascal's triangle over here so we can remember it. And we have to go up to row 7. Now you're not going to have to do this all the time because you're going to have the Pascal's triangle. But 1, 1, 1. So after you know that it starts with the first 3, then you go 1, 2, 1. 1, 3, 3, 1. 1, and you go 1 and 3 is 4. 3 plus 3 is 6. 3 and 1 is 4. 1. 1, 5, 10, 10, 5, 1. 1, 6, 15, 20, 15, 6, 1. And my last row, 1, I don't have it, 7, yep, 21, 35, 35, 21, 7, and 1. Alright, so I want you to grab your coefficients here, and I want you to try to do your variables. Remember, your first one goes up, second one goes down. So I want you to try to do the exact same thing now with your coefficients. Remember, your degree is 7, so you're going to start with R7, and I want you to do the same thing. So I want you to put your coefficients first, and then do your variables. Is that blood? Alright, if you're not done, do it with me. The first thing you had to do is put your coefficient. So you have 1, 7, 21, 35, 35, 21, 7, and then 1. Then your second one you have is R's. So you go R7, R6, R5, R4, R3, R2, R1, no R's. And then you do your X's. 0, X1, X2, X3, X4, X5, X6. And you just have to make sure you put I should probably put my pluses with my coefficients at first. So that is your, or x7, x5, x6, x7. I should have not squeezed it in there. Can you guys read? Did you guys get that? Or do you guys need me to rewrite the bottom? Got it? Here, this is bigger. So, if you need to see it. Because we had x6 and then x7. Alright, because it always goes so ours went from R7, R6, R5, R4, R3, R2, R1, so forth down. Then your x's 0, 1, 2, 3, 4, 5, 6, 7. Always goes up. Alright? The first R, because see how it's 7, so you have 7, 6, 5, 4, 3, 2, 1, none. And then the other one goes up. So it's x is none, 1, 2, 3, 4, 5, 6, 7. The other thing that I want you guys to realize, no, you can go to the bathroom. The other thing I want you to realize is your numbers, your degrees, or your exponent should always add up to what you have if you have two variables. So look at, this is 7, this is 6 and 1, that's 7, 5 and 2 is 7, 4 and 3 is 7, 3 and 4 is 7, 2 and 5 is 7, 6 and 1 is 7 and 7. So they should always add up, and that's your second way to check.
So would you add like terms and simplify that?
There are no like terms.
Okay.
R squared, to be a like term, it would have to have another R5 x squared.
Okay.
And with Pascal's triangle, you'll never have like terms.
Okay.
Yep. With so, okay, just wait. This, right now, this is only if we are blessed with having just an R and an X with no variables. Now, I will tell you, it doesn't get too much trickier. However, we do have one more step to do. So, now I want you guys to flip your paper over. And we're going to go back to the one that we skipped. Now, I do believe still that this is easier than expanding, but it does take a little bit of time. The first thing I would do if I were you is I would pretend that this is, I guess I'll use A and B because it might help you. A and this is B. And it's just cubed. So I would say that it's A plus B cubed. That's what we're going to pretend that this is. Just for a second. Or not for just a second, but just for at first. So the first thing you have to do is what? What do you always do? You do your coefficients. So I'm going to write down my coefficients. I'm going to go to what row? Third row. So my coefficients are 1. I'm going to actually go plus 3 because it's going to get kind of complicated. Plus 3 plus 1. So that we can, because remember you're going to have those symbols anyway, so you might as well do that first. So the second thing is to do with your variable. So I'm going to go A cubed. So I'm going to go A cubed, A squared, A, no A. Then you go with your B. 0, and then this is 1, and this is 2, and this is 3. I want to get to that point and make sure I'm going to stop, wait, see if there's anybody that has questions. Because this is hopefully the easy part. The next part's not hard, it's just that you have to be paying attention, really. Anybody not know how I got those? Everyone's good. Thumbs up if you got it. Alright. But what was A really? 3x, right? So we're going to bring the coefficient down and we're going to put parenthesis 3x end of parenthesis cubed plus, bring my coefficient down, 3. But a wasn't really a, it's 3x. So I'm going to go 3x squared but times b, which b was what? Negative 2y. Plus, what do I do now? 3 times 3x negative 2y squared plus 1 and then negative 2y cubed. I'm going to wait and make sure everyone understands where we got those. All I did was substitute in for what we're using. After this, it's strictly just clean up. Just clean up our mess. We have here, I'm going to leave my 1 just to show you where it is. 3 cubed is 27 x cubed plus 3 times 3 squared gives me 9 x squared times negative 2y. I'll get that on my second time through. Right now I'm just going through and doing my squares and cubes. If you haven't, if 3 times 3x times negative 2 squared is 4y squared plus negative 2 cubed is negative 8, so I have negative 8y cubed. Last row, last time through, is to clean up our final cleanup, meaning to multiply any numbers we have. So we have 1 and 27 gives me 27x cubed plus 3 times 9 times negative 2 is a negative 54x squared y. Then we have 3 times 3 times 4. 36 x y squared minus 8y cubed. Yes.
I don't understand like that with negative 54. Like I understand that you're like combining, but
What's 3 times 9 times negative 2?
yeah, I understand that's 54. I think I just wrote it down.
Negative 54.
Oh,
Yep.
We think of like each one, like back up to like the 1A cube and all that, like one little, like oh no, like when you were done from the half of the triangle, like the first line of stuff that you wrote, yeah, that's fine. We think of that as kind of a chunk, so it's like we simplify that chunk as we go down.
You're simplifying this. Like this is what you're simplifying.
So you can't jump to like the next one, we simplify.
Yeah, this to there, this and this is all multiplying together, so you have to simplify that. Yes. You have to multiply the numbers in, well, first you have to square it.
Are you just getting rid of the variables first and then the exponents?
You are squaring. 3 squared is 9. You're squaring, you're getting rid of the parentheses and you're multiplying it together. So, alright. I'll come over and work with you in just a second. What I want you guys to do, flip it over, and I want you guys to try number 3.